Alrighty, let's get started. So, today we're going to be continuing work on the Mandelbrot viewer, which we have here. Let's just do this. We'll see where we're at. So, this is what we were up to last time. Not that I want it there, maybe that's a bit better. So, yeah, last time we started drawing this at around, depends on what's going on, I guess, a little bit here. Around 1500 frames a second. I'm not really sure why we're getting some of these laggy frames here. In any case, lots of that could probably be fixed by modifying that shader. By doing some stuff in the fragment shader. So right now we're doing like some fairly expensive math here. 256 times for every single fragment on the screen, which in this case is going to correspond to a pixel. So we want to do something there. But first of all, I actually wrote a to-do here so I don't forget what I was supposed to do. So yeah, so first of all, none of this has been added to Git yet. Actually, before I do that, I just remembered there's something else. There was a bug last time. It took me forever to find because I was dumb and used single variable names, which is never a good idea. So instead of doing that, we are going to rename these quickly to vertex and fragment. So a vertex, up in there, vertex and fragment. Vertex, fragment. And then down here, we're gonna free these. Have a comment there. We're gonna get rid of this freeing altogether soon. I don't like using free or malloc or any of that nonsense. So that looks good. Let's make sure we didn't do any bugs. So we're good there. We can maybe restart this. Remember which order to do this in so that you can still see what's going on there. But so yeah, that's that now. Let's see what is it to do. So add stuff to Git. So that is a good first step here. So let us git init dot, and we'll git add build fragment vert main, and that should be it. Yep, we don't want to add those things. Yum. So cm is just a alias I have in my git file for commit -m with a message, so I don't have to type stuff. Start drawing the thing and put in a passphrase. So There, we're only at 309 lines and we're already drawing this, so that's pretty good. So that is the first step. Now I should add some remotes here. So we're going to add an origin, which will be my website. Oops. And we will also add a GitHub, which I have made. I don't remember the Git thing ever, so I'll just copy and paste that one. So we can now push to origin, which are actually, yeah, before I just do this, I need to add like a license. So for now, I'm just going to copy one of my other licenses, which is probably ISC license. What is this? Yeah, this is ISC license. This part is not ISC license, but I don't have a UTF-8 decoder here, so be good if I could type that email address correctly, but the git commit is correct, so that's fine. So this will just be ISC license for now. C license or licensing details. I might have made a little bit of a dumb here. First. Oops. Probably I'm going to turn this off a little bit, but we will see. Let's make sure that that doesn't break any of the shader. So that is fine for now. I don't think I can actually amend that first commit, so I might just delete the old .git folder and re-add this. I actually think I'll just do that. So let's go back through history here. License. And then we'll add that one. Origin, git push. .u origin master. Well, that's not going to help if I don't make the same commit. So start drawing the thing. .u origin master. And then GitHub. Make sure that that's all looking up to date. I didn't mean to refresh that one, but it's fine. That's all looking good, so you'll be able to find that on my GitHub. Now, so we do done that. Hot shader reloading. So we don't want to have to restart Mandelbrot every time we edit the shader. So there's some easy ways of just doing that. I'm actually going to combine that with this thing. So right now, the code just runs on Linux. But I happen to know where all of the code is that would be OS specific, and basically that's just around allocating memory. And actually right now it's not even about allocating memory because I'm using malloc, but we'll change that. And it has to do with opening files and statting files, and that's basically all it has to do because I'm using glfw for opening the window, which is nice and generic. Or not nice and generic, I should say, nice and cross-platform. So what we will do is open up main.c and we will start splitting up some code here. So let me open another file, which I will call osunix.c. And in here, we are going to take unistandard and whatever this file descriptor control, whatever that header stands for. And that is that for now. So we had this read file function somewhere. How did I do this? Yeah, read whole file. So this is going to be OS specific. Obviously it is because we're using the open system call, closed system call. Neither of these exist on Windows. We're using lseek. Actually good, because I hate lseek is really slow. I shouldn't be using lseek here, but we'll remove that as well. We need to do this. We need to remove this anyways. Well, we don't need to remove it, but there's a better way of getting the file size if we're gonna also be reading the, if we also want to do the hot loading. So we'll take this code into here. And we are going to do my stupid thing. So I don't like doing any of this nonsense, headers, whatever, garbage. I like to have a Unity build. So I only need to build the one file. So basically somewhere after these type defs, really this doesn't need to be even shown up. This isn't even going to show up in here. So after this type def, these other type defs are not really specific. So we are just going to do down here, pound include osunix.c. Oops. I think my key on my keyboard is almost dying, so I'll have to replace that at some point. But and we will also do some if def guards here. So if def Unix, I believe, is a valid one to just use here. Just check some other code where I have done this, so I remember, because I don't really always remember what I'm doing here. So yeah, I have used underscore Unix before. I've also used underscore Apple. I think I'll just ignore that for now until it's proven that I need that one. When someone tests it on Apple and tells me that I need that, until then it will just stay as Unix. And then otherwise we'll do error unsupported platform. So that is that. Now we will I don't know if sometimes I like to do os underscore read whole file, or even just read file. It's not really necessary. I don't know. We will leave it like that for now. So first things first is we should just make sure I haven't completely broken everything. So we will just make sure this still builds. So yeah, that's a good point. Read whole be replaced with os underscore read underscore. Okay. Everything is still working. I want this to do that, please. Everything is still working there just fine. should probably not be doing this because it's a little taxing on the CPU. So for now, we will just do the thing which I disabled before, which is I will re-enable the heck was that? Oh yeah, here, swap interval. So for now, we will set this back to 1. Let's comment this out. So we know that the default is that. So that will just, while I'm doing this, it's gonna lag. Well, if I were to recompile it, it will lag. It will be a little bit less taxing on my CPU while I'm streaming. So we'll just leave that up for now. So we're not just blasting through a million lines of stuff every time. So, so far, there's this code is okay. But I don't want to use lseek anymore. And actually, let me just check quickly. Is there any other code that is not supposed to be, is not OS agnostic? I don't think so. I think everything in here should be completely agnostic of the operating system for the time being. So it is. So what we will do here is so how do we determine if the shader file has been updated? And if it has, if it has been updated, we need to basically reload the shader. So to do that, what I usually do is use the operating specific file time. Now, the way you do that on Linux is using the stat and stat system call. And actually, it's going to tell me to go and look at this page instead. So we want to use this stat system call, and this stat system call, which it doesn't actually say in here, but if we look at the man page for sysstat.h, is it's going to give us this stat structure, and this stat structure has a couple useful things in here. So first of all, it has the last access time, the last modification time, and the last status change timestamp. Now, some of these are going to be dependent on how you've configured your file system to be loaded in Linux. But for our purposes, this st mtim, like this last modification time, is sufficient. So we need to get this one. And then also there's this other useful size, which is the size. Now, as I happen to know, using stat is much faster than lseek if the file's big. If the file's small, it doesn't really matter that much, but and we probably will be dealing with small files, but we might as well not bother using this if we can just get it out of this same stat function. So what I'm going to do here is I'm going to add some sort of new type here, which I'm going to call, going to be a struct, and it's going to be OS file stats. And in here, so on Linux, there's a couple ways of doing what I want to do here. So first of all, size is just going to be the file size. Or sorry, there'll be a size member that's just the file size. So we can just cast this st size member to this. But for the timestamp, I don't want to have struct. So there's a few ways I could do this. I don't really want this. I don't really want to have this struct time step spec thing because this is like Unix specific, I guess. So like Linux or BSC. Um, and I want to have a file. I'm gonna have a function down here that's gonna be like static int I32. I think I have that type defined. It looks like it. And it's gonna be os compare file time because I happen to know that on Windows there's a function that does a file time comparison based on the Windows file time type. And so I don't want to have to put in this prototype here. Well, technically you could put like the specific operating system ones here because this is only being compiled. So this is only being compiled on Windows. I mean, sorry, on Unix. Yeah, actually, that's a good point. Um, huh. I don't really like that name though. So type defing stuff is technically free, so I will just do that. So type def struct time spec, and we're just gonna call this OS file time. Um, then in here we will do OS file time modification time stamp OS file time modification time. Uh, yeah, yeah. You know what? Yeah, it's fine. We'll be verbose. That's okay. So this function down here is going to take OS file time A and OS file time B, and it's going to do some sort of comparison, which I will do after. So for now, it will just return 0. So we need to read some stats. So we're going to define a new function here called that's going to return a file stats. Sometimes you might want to pass this in as like a out variable. Right now this isn't very big, so this is like 64-bit, and then this has, I happen to know that this time spec has two 64-bit numbers in it. So it's only three 64-bit numbers, so I don't really care about passing this by value. It's not much of a problem doing that, so we will do it this way. So OS file OS get file stats, and it will take a file name, and that should be all. So let us look at this fstat at function. So first of all, we need this header. So let's include that. And then the stat function here is going to take a path and a buffer for the output. So let's copy this, and we will do struct stat buffer. I don't even think in their example code they like initialize it. They don't, so that's totally fine. And this is gonna take the file and SB. Check this for errors. So if this is less than 0, I believe that is the return value for this if there's an error. Okay, specifically if it's -1, but I don't really care that much, so this is like a total micro optimization, but the CPU has a comparison for less than. It doesn't like less than 0 specifically. The status flag will get updated like this. So, checking against equals to 1 is kind of like, nah, and I have to load that in. Really completely doesn't matter, but I just happen to know that, so I never do. I try to avoid equals minus 1. So here, return value. So if it's less than 0, so that is fine. We will just return an OS file stats that's empty. We could do like some other error. I don't really care that much. If if the modification time is 0 or the file size is 0, there's probably an issue. So add space here. So that is that. So then now that we've got that, we can do a return again, OS file stats. And I forgot to do something. So in here we will do dot file size equals status buff dot like st whatever it's called, st size, and modification time stat equal to stm time. Oops. Good. So that is looking good. Now that is not a keyword. That all looks good to me so far. We will write this other function in a minute here. So let's go back to main. Now, in here, we need some way of checking the modification time and comparing it to how did we do it here? So we have this program from files. That is good. I don't know if we can get away with doing one or the other. I'll have to look. I don't know if you can. Technically, we could like keep the other shader around and not delete it from the GPU, and then just relink it. Since these files are small, I'm not sure I'd really care to do that. We can just reload both of them every time. Doesn't seem like that big of a deal. So for now, that's what we will do. So I want to do something a little different here now. So first we need to get a file time. We are going to get two file time, OS file stats. We're going to get two of these. So first of all, we're going to get what should I call this? Shader stats. So for this one, we will do the OS get file stats. Actually, there's two of these that we need to be checking. We could technically update either of them. So Really though, um, you know what? I'm not going to care about it. So right now we're not going to be modifying the vertex shader. Eh, I'll just do the thing. Fine. So sometimes in my other programs, I like to have the vertex shader and the fragment shader in a single file, and I just split them. I'm not doing that here, so there's going to be like some different things here. That's fine. Um, and fragment stats, and we'll have a net free. Let's rename this. Test. So let's do it this way. Let's initialize that for just because it doesn't really matter, but we'll just do that. Now so we'll change those other things after. Let's do this first. So if now we're in this main loop, every time through this loop, we are going to check. Sorry, I don't need to have this outside the. Don't need to have that outside this loop. So every time we're in this loop, we are going to do a little check here. What's happening? Hello. Okay. OS file stats test is equal to test stats is equal to and maybe even I'll scope this for now, though it doesn't really matter, but we'll just do it anyways. So let's just scope this and we'll do get file stats vert please. And then we will do if did I call that function? It's called OS if OS compare file time test stats dot modification timestamp. Maybe this is a little too verbose. Uh, yeah, let's rename this. We're just gonna call this variable timestamp. I don't really care about modification timestamp or whatever. Too verbose. Do not care. I can align this. Okay. And vert stats dot timestamp. Then what we need to do is add a comment, add a comma here. And then what we need to do is do vert stats equals test stats. And So let me think. So since we are doing this, honestly, this doesn't need to be scoped. And since we are doing this, I'm a little tempted to not reload the shader here until we check the other file, but um, oops, I need this whole line actually for that matter. And I need to make sure that we do a couple things here. So I actually need to make sure that this gives me a new program ID. If it doesn't, we're not going to reload the shader. So if PID does not equal -1, PID is greater than 0, we are going to do a little bit of this. The GL delete program, I think it's called. Just check quickly. So I've written some nonsense thing here, so let me see. Yeah, it should be GL delete program, and you just pass it the PID, and then we will assign this new one. We will assign PID to the new one, and then we will do a GL use program. I do wonder if I should move this into a little function, because there's going to be like some duplicate nonsense just going on here. I might just do that so that I don't have this duplicate code. Let's write a function here that's going to be, it's going to return an OS file stats so that I don't have to update this stuff. And it's going to be static, obviously. It's going to be called check and update shader. It is going to take it's going to take the shader that you want to compare, the stats, the test stats, and it's going to take the name of the file that you want to compare against. Not like that, obviously. And then we're going to copy all of this. And this will be the new stats. And that's what we're going to return. And we were going to replace this with test file. and we are going to do test stats.timestamp and new stats.timestamp. We're not doing this. And we do okay. So if it passes this test, we're going to load a new program, and then we're going to delete. If that new program was successful, we're going to delete the old program. We're going to assign that, and then we're going to use this new program. So PID, or for good measure, I'll just put this one directly here again. And that should be that for that function. Now, we have to, down here, every time through the loop, we're just going to call this function twice. And we are going to do, so vert stats is going to equal this. And take the old vert stats. And it's going to take the vert.glsl. There's some like annoying things like having these hard-coded names in here, but for now I'm just gonna ignore that. Don't care. Don't really care. And then fragment stats and fragment stats and frag.glsl. So now if we just go and write this os compare file time function, we should be able to do some hot reloading. So, not down here. So this function is a little annoying to do on Linux because basically there is two U64s in this. So in these time spec, there's two U64s. There's I think it's in like time.h actually, where that's just defined. Actually, it might be systypes.h. Time spec. No, it's in time.h. So yeah, here we have this. We have a TV second, like this time value seconds member and time value nanoseconds member. So basically what that means is that we have to do something to compare. You basically have to construct the proper time, with seconds and nanoseconds, and compare it with the for both of them, and then we have to compare those two numbers. Now there's a couple ways you can just do that. Now, usually what I do is, well, let's just do it. So we're gonna return, so the thing with like any of these the thing with any of the comparison functions in the standard C library is like, you basically return 0 if it's the same. So, what we will do is do the same thing as that function would do, which is return a.tv sec.b.tv sec, and going to add, and I might do this on a different line here because it's going to get long. A.tv nsec minus b so b.tv nsec. And we are going to divide this by 1e 9. So actually, that's like not right. Oh yeah, sorry, that's correct. Yeah, that's correct. So these are nanoseconds, so they're like some value, like 1 nanosecond would be is this right? Is this even right? Uh well, no, this isn't right because there's like yeah, there's a problem here if this returns an int where this value is just always getting truncated. So um let me just do this the correct way. What do I want to do here? So either we can just ignore that and just rely on the seconds member, but since we have the nanoseconds, we should probably do the proper thing, which is to basically say that, well, technically we don't need this delta at all. So yeah, basically this is fine. Who cares? This is correct. We don't actually need to, we don't need like the proper time delta. I just need to know if it's different or not. So this is sufficient. Though there's probably a case here where this could like return 0 when the times are different. Not really sure. It's fine. Who cares? Most likely it's not gonna do that. Um, yeah, so that should be good. So let me just make sure this builds. Well, that's one good problem to fix. I don't know what I typed. GL use program. That also needs to be fixed, obviously. Program. So now if we close this and reload it and do this correctly, so now what we should see is that I should be able to update the shader. So let's open the fragment shader. And we're going to change some values here. So well, let's say instead of R, we want to make it green. So we'll just do this. Hey, look at that. So now what we can do is we can change whatever the heck we want in this shader, and as long as the shader still compiles properly, we can just update stuff here. So say we want to make this default color a little cyan-y. Well, cyan would be like more blue than that. Something like that, and then yeah, so something like, well, okay, well, anyways, that's fine. What I'd like to do though now is actually just do the, I'd like to do these Okay, well, let's take this in steps here. So let's look at our diff. We're gonna ignore the shader diff. So the main.c, this part is whatever. Probably skip that. All this stuff though should be good to go. Let me just check what is going on in here. Okay, probably want that there still. So that is looking good so far. I want to change this color. I don't like it. So we are gonna do this and do this and do and do maybe. Oh, that's too much. Purple and green. No, I don't like purple and green. We want to do purple and blue. Purple and blue is like hard to see. I think what I'd like to do is have this other outside part be light, but to do that we have to do something a little bit more fancy with this color. So so we should not make this purple. Purple and blue is like difficult to see. That's like way worse. Oops. So let's make this like not blue. Red and green makes yellow. Poop. No, that's an awful color. No, 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 no. Absolutely not. We'll just do that for now. That's fine. So that's good. Um, and what we can also do is, well, we can do this to get rid of this annoying lag. And that means that I did something stupid. What happened there? Huh. It's a good question. So let me just leave this and restart and see if that is still a problem. That is actually a good question. So we should actually see what's going on there, because that shouldn't happen. That is probably a bug. Uh, in the driver. So, well, that's not going to be super helpful for us, is it? Thank you for your help, driver. Um, I don't know what I did wrong there, to be honest. Uh, yeah. Yeah, I don't know. Good question. That is a good question. this break? There shouldn't be like any reason why that doesn't work, to be honest. Should probably like get it to break while we're in the program, but yeah. So I don't know what is going on there, but for now I'll just leave that as it is. I don't really know why that would break. Because you should be able to you should just be able to decrease this iteration count. So what about this one? Yeah, so that one works. Um Wild. Not actually sure. Let's like make this a little brighter. And then since that is brighter, maybe make this one brighter as well. So there we go. Yeah, I'll have to check. I'm not really sure why that's crashing when that happens, to be honest. Um, you should be able to reduce this count without it crashing. Weird. Okay, that's fine for now. Let us go ahead and add some code. So that is good. That is good. This. Well, hopefully this is fine. I don't want to use that change. This part is all good. That got moved to the other file, which we'll add. This is fine. This is fine. Good. It seemed like there was maybe a white space error here before. Make sure that it's not there. So now main should just have that one. And we need to git add os, open this, open main, copy this, close. We're gonna add this file. Hot reloading. Add shader hot reloading. I'm gonna amend that one. Add shader hot reloading and also move file reading to OS specific file, platform specific file. Call that. Okay. That is looking good. So what to do? So we got that one done. Did that. Not sure why I put this one here. I don't know if I'm going to be doing that. Let's see, what time is it? Oh, we can probably remove malloc. What is that? Oh, I see. Yeah, so actually we don't want to do this anymore. We want to use an arena. So let us start doing that. So we're going to type def. Honestly, it doesn't really matter for like how little data we're dealing with, but just for the purpose of deleting malloc and free, I'll do this. So type def struct u8 pointer beginning, u8 pointer end, and that is going to be our arena. Now I'm not going to make this variable size. I'm just going to do some fixed size stuff, and I'm going to also do something really naughty, but I don't really care that much. So we're going to do this. Static. New arena. Actually, let's call it get arena because yeah, I'm gonna do something a little naughty here. We are gonna do a static char data, and this data is just gonna be I don't know, like 8192, like 8K. So let's just have a look here. So the fragment shader is no, let's make it. We'll just make it a little bigger. We'll make it 32K. So what would 32K be? It's just gonna be 32 times 1024. Don't really care about doing math. This is perfectly fine to be allocated on the stack. Don't think this will cause any problems. Also, this needs to have a return type, static arena, and then technically there's something you're supposed to. Okay, yeah. So like this is not really supposed to be. If we were to just return, like basically what I want to do here is to return arena um dot uh, dot beginning equals data dot end equals data plus 32 times 1024. Technically you're not really supposed to do this. You're not supposed to for a couple reasons. Like the compiler really is going to complain if I just do this. I will show that right here. So I don't need that much memory. I don't want to use like the OS specific allocation files because it's kind of pointless. So Well, okay, there's this error first. Why is this a double dereference? I like typo something. Okay. Anyways, I'm surprised it didn't complain to me about returning static memory, but there's this thing about pointer aliasing that we kind of want to be careful about here. Now, I'm not sure why that was even complaining to me, to be honest, because this is a pointer and this is a. I can do this if it wants. um, that should shut up. No, I don't know what that warning's about, to be honest. Incompatible type. Like, this is not a. There's no double pointer going on here. I mean, technically it should be that, but um, for some reason it still thinks it's just a double pointer. I have no idea why. But anyways, we are going to do something a little naughty here. So, um, what I'm going to do here is use something that so let me just bring this over. So there is this guy, Chris Wellens, who has tons of interesting coding whatevers. So in it, he talks about arenas on one of his articles. He has plenty of other interesting articles, so you can check them out. Um, Specifically, what we're interested in though is his dirty hack somewhere down here at the end. Here we go. So it's technically not permitted because you're aliasing pointers that you're not supposed to be aliasing by doing this. I should actually add this. Well, I don't really need this thing, but I'll do this sort of allocation trick. So yeah, we're gonna do some dirty pointer laundering here, where we're just gonna use some inline assembly to get around the fact that what we're doing is not allowed. um, so basically, what we're gonna do here, go back to our get arena call. Let's do it this way, just for the sake of so yeah, so just this. He called it a dot beginning or r dot beginning. Clean up your dirty laundry, boy. So, by doing this, by using inline assembly, from the compiler's perspective, it has no idea what this assembly is doing. For all it knows, we've called into some random assembly function, and it has gone and modified this pointer here. So now this pointer is no longer this pointer. It's no longer considered to be this data pointer from the perspective of the compiler. This inline assembly could do some weird nonsense, and basically not even weird nonsense. It's just going to modify whatever this pointer is. So once we've done that, we're allowed to. It's no longer going to be against the rules to launder it. The compiler can't make any assumptions about what pointer this a dot beginning is anymore. So then we will just do our little thing here where we assign this to a dot beginning plus this. And this is technically correct. I want the end of the pointer. I don't want I want the last. I want one past the last element. I don't want the last element. So this part was wrong. And then we will just return our little a here. So yeah, so I should do a little casty doodle here to get that to shut up, but besides that, besides that is not where we want to go. Besides that, this should all be correct. So we're not using this yet. That's okay. So where do we need temporary storage in this program? Just take a look. So we need temporary storage here. So this thing here will take an arena. And instead of allocating space here, we will do alloc, which I have to define here, which will be from the arena. And it's going to take a pointer to the arena, and it's going to take a type, so in this case, char, and it is going to take a count, which is len in this case. And we're not going to free this anymore. And then compile shader is called by what? This thing. This thing needs to take an arena. And it needs to pass that along to compile shader. And it needs to, well, we're not doing it here, but the reason we want an arena is so that we can do this. So, and then we don't have to free this down here anymore because it is coming out of our arena. And what we are going to do is, first of all, we are going to write our arena alloc function way at the top here. Yeah. It's a bit of annoying. So usually I would have this in a separate file called util, but I don't really necessarily, well, since I need this to be, I need the OS files to have access to this function, and I don't want this to be like way. I don't want this to be way lower down. Let's add it up here. So we will include a util.c. Just so that I can do this without doing the weird thing. So in here, we are going to define a macro called alloc, and it's going to take a, t, and len or size or whatever you want to call it. And that is going to be a macro for alloc underscore, which takes a few parameters. It takes a, it's going to take, what's it called? Check my notes here. So, where am I using this? Not in this code. So it's going to take a, it's going to take the size of the type. So t is a type. It's also going to take the alignment of that type, which, I mean, in this case, we're not doing anything crazy, but we're just allocating, you know, U8 data. But anyways, so it's all, the alignment's always going to be 1, but that's okay. And it's going to take s, our size. Maybe it should be called n. N's like a better name than size. So then we're going to do some compiler nonsense, where we can set the attribute of this next function we'll define so that the compiler can actually know what's going on, and potentially warn you about, you know, applying stuff in the wrong order or whatever. So then we're going to define our alloc function. So it's going to take an arena pointer, take a size, len. It's going to take a size alignment, and it's going to take a size count. So now, tempted to ignore this alignment, but in case I decide to go and have some more allocations later, I'll just write it for now. So, oops. So padding is going to equal minus, why is it minus? Because we need to basically, sorry, because we need to, yeah, sorry. I need to write the actual code first. So I don't even know if I need this cast here, to be honest, but let's just do it. So a to beginning. So we're gonna add, we're basically gonna do some pointer arithmetic with this padding to make sure that when we go and add some value to this, it gets added properly. So we are going to negate the beginning of this pointer. So now it is like minus whatever the address of the pointer was. And then we are going to do some little bit of a tricky here, where we can add it with align -1. Which is basically going to clear, so let's just do a little comment here. So let's say the alignment was 8. So 8 in, well, let's do it in binary. 8 in binary is going to be, let's just talk about a single byte. So it's going to be 0, 0, 0, 0, 1, 0, 0, 0. So there's our 8, our alignment of 8 in binary, okay? So 8 minus 1 is going to give us 0, 0, 0, 0, 1, 1, 1. So what we do now is we say, okay, the beginning of this arena is some value. Now that value is like some pointer address. It's some address, which is going to be I don't know what the address is, but like a common address for stuff that's allocated on the heap is like 7FFF. I don't know, 7FFF. Let's call it 7FFF. Uh, uh, cafe babe beef. I don't know. Sure. So that's our address, let's say. We got this weird address. Now if we negate this, if we cast this to like a uint pointer t type, so it's like an unsigned pointer type, and then we negate this, we're just gonna get like the flipping. We're gonna flip all this around, but that doesn't matter. What we're gonna do then with this and alignment is we're gonna mask off like the lower bits of this. So the lower 3 bits, in this case, are gonna tell us we need to be aligned on an address of 8 when we're done. So if we take the lower 3 bits, if they are like some value that is not a multiple of 8, it could be any value from 0 to 7, we're going to get a value here that is basically something that is, padding is something that's either minus 0 or all the way up to minus 7. That is what our padding value now stores. Okay. So if we need to now align our thing, so before we do this, let's just calculate the number of available bytes left in the arena. So this is going to be a.end minus a.beginning, or a to beginning, minus the padding. So this first part tells us the length of the vector, the length of the available data. Now this could be like some random number that's like got some odd component. So let's say it could be like, I don't know, 53. 53 is obviously not a multiple of 8. So we need to subtract some padding here. So this is like seems a little wrong to me, to be honest. I should like really review this to be fair. Let's just keep writing the rest of the code, and I will see if this looks wrong. It feels wrong. Feels wrong, but I'm not 100% sure. So if available is less than 0, or count is greater than available divided by the length, we're gonna have an assert macro. I don't have an assert macro right now, so I'm gonna do something stupid, which is basically we are just gonna crash the program. So we're just gonna do a null pointer to reference and crash ourselves for now. And add it to do here. Handle error. Otherwise, we are gonna do a void pointer beginning. A void pointer p is equal to a to beginning plus padding. This looks like wrong to me because the padding value here, is the padding value negative? I feel like the padding value has to be, because I'm using like a signed type here, the padding value has to be negative, right? So let me just check here. Yeah, so the padding business here should be correct, but let's delete this stuff. Yeah, I'm not sure. I'm pretty sure the padding here is correct. I'll have to think about it more later. But basically, what we're trying to do here is just make sure that um, whatever value we end up with is on a common multiple of 2 or 8, 2 or 4 or 8 or 1 if you are using UNA pointers. But anyways, so that should be fine. So that pointer is equal to that, and then a to end, a to beginning plus equals count times length. I believe that is all we need to do. Now, possibly you want to clear this memory. So I will do that. Oops, not len-g. I will also do that. I don't want to use memset, so and it will just take p 0 and count times len. We'll just define this up here. So void pointer mem clear. It's gonna take a u8 pointer p a what's it called? A u8 clear value, like a character, and then a size length. And it is just going to do the most basic thing. While len p of minus minus len equals c, return p. That should be that for the arena alloc. And then let's have a look here. So, right. So this thing, this thinger, this part is fine. Now, read file, we want that to take an arena. And also, I think we want that to take a length so that we can get rid of this lseek thing. Because we already have to know what the length of these files are anyways, so... and this should take a pointer to an arena, specifically because it is not temporary. So, don't need that one anymore, don't need that one anymore. Don't need any of this anymore. Don't need that, don't need that, don't need that. Alloc a u8 ret.len. Not ret.len. File size. Interesting. I wonder if there was like an error here before. Spaces. So that looks good to me. Not quite. So ret.len equals file size. Okay. And then here we need sure. So this one, oops. These ones need to be pointers, but this program file doesn't need to take a pointer because it just is supposed to free the data at the end. So v file size, not v file size. There's my stupid error from before showing up again. Okay, so this all looks, clean up your dirty laundry. Or clean up your dirty boy, but that's something else entirely. This will take memory, and it's gonna take vert stats dot file size. This is starting to get long, so we're gonna do some of this, and it's gonna take frag stats dot file size. Okay, and then check and update shader stats. This one needs to also take an arena. That's going to pass A to that one. And the same thing again. Dang. This is actually a little annoying, the way I've done this. So maybe this is going to get moved back outside into main, because I don't want to have to pass. Yeah, I don't want to have to pass that every time. So we're going to actually delete that and move it into main, because then I don't have to do this. Okay, so um yes, the one thing I can do here though is just, so I'm gonna get rid of that. And we're gonna go ahead here and we're gonna do if OS compares file times new is to vert stats dot timestamp new vert dot timestamp or OS compare file time frag stats dot timestamp new frag dot timestamp. Then in here we can go and do the code. So take this so that is like that, and then program from files memory. Yes, okay, that is correct. Then if this was successful, we will assign these fragment stats equals new fragments equals new frag, and vert stats equals new vert. That looks good to me. And we can delete this and all this white space. Okay. Let's see. Have builds. I guess we do here. and that runs. Good, awesome. So let us make sure that this stuff still works. So I am going to go down here and not change that because that is broken. We'll do this. And that is still working all nice and dandy, so good. I think with that, that is gonna be, let us commit this and push it. Looks fine to me. I'm not seeing any problems there. Not overrunning our okay, so that's, yeah, we need to make sure that's correct. So this part is good. We skip that. This is good. So we do our alloc. We don't free it anymore because it's from the arena, which was passed by value. So that's good. Then we do this. I'm gonna read the file. We need to save those. That's good. Then we do our compile shader. Good. We don't free that data anymore because it doesn't need to be freed. Perfect. And then we have some get arena function, which looks fine to me. Just launders a pointer. Then we have our memory. That's good. That all looks good. Good. So we want this. We don't want this. We want this. Want. Good. Open this. Open any of these other files. Yank this. Good. It's good to me. And now I want to check something. So there should be no more malloc. Nope. No more malloc. And no more free. So that means we can go into main here and we should be able to remove standard lib because we're not using standard lib anymore. Yep. No more standard lib.h. That's nice. So should have done check that first, but that's fine. No more standard lib. I don't know what happened there. I deleted a line too many. There we go. No, okay. I'll just do what I'm supposed to be doing. Desync. Bye. There's like apparently white space there as well. That's fine. And that should be good to go. Replace malloc with arena. Good. good to go. No more OS specific memory allocation. I mean, no more mala, no more free, no more memory management, I should say. We allocate 32K at the start, and that is all we allocate. We do a top here. Probably don't want to do that, to be honest. I don't know why I didn't load there, but I don't want to do that right now for multiple reasons. Let's just make sure this is all nice and working. Good. So let's do a git push and a git push GitHub. And we're good. So we've now got hot reloading of the shader. Everything's looking nice. So for next time, we can just start working basically completely on Mandelbrot stuff. So the first thing we want to do is come up with a better color scheme, I think. And then after that, we will do something like adding the zoom function, probably based on where you put the mouse. So yeah, that is that. Thanks everyone for watching, and I will see if there's anyone actually watching. And if there is a lot of people watching, then what I will do is raid someone. So I'm not seeing anyone right now, so that is fine. See everyone later. Bye for now.